A monomial is an expression that is either a number, a variable, or the product of a number and one or more variables. A binomial is two terms, so it's the sum or difference of two monomials. And then a trinomial, which is what we'll usually work with for factoring, is the sum of three monomials. So these three terms, we usually just call them terms, but they are considered monomials. So when we factor, we'll usually factor a binomial or a trinomial. When the process of multiplying polynomials is reversed, we call this factoring. So we've worked with putting things into standard form, so that's this one. When it's factored, it's these two terms multiplied together. So like if you took 3x minus 2 times x plus 4, like you FOILed it back out, or you took the time to multiply it back together, you would get this expression in standard form. So the purpose of factoring really is to solve a quadratic equation. It's one of the more common and more useful ways we'll use in this course to solve equations. But factors are two or more numbers or algebraic expressions when you multiply together, and is called a product. So by themselves, 3x minus 2 and the x plus 4 would be factors of this trinomial. So when you guys are trying to factor an expression, the sum of these two terms multiplied together, so like negative 2 times x, 3 times 4, 12x, has to equal your middle term. And then when you multiply, the first term multiplies to get you the first term. Last terms in each factor multiply to get you the last term. So negative 2 times 4 would be negative 8. We'll get into the more complicated factoring tomorrow. We'll start you out with a simpler, with a lead coefficient of 1 today. So when you're trying to factor the expression x squared minus 9x plus 20, we want to get two sets of parentheses, each with a factor that if you multiplied them back together, we'd end up with what we started with here. So 20 is what you're trying to multiply to get, and negative 9x is what you're trying to add or subtract. So we're trying to think of numbers that multiply to get us 20. So like obviously 1 and 20. You could do 2 and 10, 4 and 5, but we're trying to think what numbers, either adding or subtracting them together, could we get the combination of 9. So hopefully you guys are thinking of 4 and 5. So the x times the x gives us that x squared. And then it's just, okay, what multiplies to get you positive 20, but adds to get you negative 9. So 4 times 5, that would be positive 20, but positive 4 plus positive 5 would be positive 9. So we need them both to be negative. Negative times negative is positive 20, but negative 4 plus negative 5 equals negative 9. So we're trying to multiply to get you that last number, add and subtract to get the middle number. So if we're looking at 12, or letter B, sorry. We're trying to figure out what multiplies to get you 12, adds to get you 3. So if you start listing factors, you have 1 and 12, 2 and 6, 3 and 4. It's not a trick question, but this one actually isn't factorable. Using 1 and 12, you can never add or subtract to get 3. 2 and 6, can't get 3, you can get 8, you can get 4. 3 and 4, you can get 1, 7. So this one actually is not factorable. We would have to solve this a different way, which we'll look at later. Okay, so now if we look at letter C, trying to figure out what multiplies to get you 18, but adds and subtracts to get you negative 3. So like 1 and 18. I know you may not have to list out all the factors. Some people it might be helpful. 2 and 9, 3 and 6. So we need that x and x to multiply to get us the x squared. But then what multiplies to get you 18 but adds to get you negative 3? So 1 and 18, that's not going to do it. 2 and 9, you can get 7, you can get 11, that won't do it. So we want to use 3 and 6. So if we want -3, we have to figure out, do we want both them to be negative, positive, and a negative? We don't want 6 minus 3, because that would be +3. We want 3 minus 6. I feel like I could write that a little neater. So x plus 3 times x minus 6. Multiplies to get you -18, but adds to get you -3. Okay, there are some special factoring patterns. You won't necessarily have to have them memorized, but they are good to just have in the back of your head, so if they pop up, we'll talk more about them later, just so that you know that they're patterns, and then hopefully get a hang of getting used to them. So the first one is a difference of 2 squares. So the difference of 2 squares, that just means difference is subtraction, and 9 and 16 are both perfect squares. So what happens is you use the square root of those terms. So like the square root of 9 and 16 is 3 and 4. So 3x and 3x would get you the 9x squared. 4 and 4 get you the 16. But by doing one addition and one subtraction, they're going to cancel out the middle term. That's why there's no middle term like there is down here in this one. So 3x plus 4 times 3x minus 4. Again, we'll talk more about that tomorrow, but just good to have in the back of your head as a pattern. They're patterns. So then the other ones are your perfect square trinomials. So that's when you've got the same binomial squared. So like when you have x squared plus 10x plus 25, that would really factor into x plus 5 times x plus 5. But you can write it as x plus 5 squared. So the really only difference between these two is this sign in the front. So when you have a plus 5 plus 5 gives you 10. But when you have a minus, it would give you that minus term first. So x squared minus 6x plus 9 would end up being x minus 3 times x minus 3. Or you could write it as x minus 3 squared. So we'll look at some on the next page, those patterns. So x squared minus 49. So we're really trying to figure out, like, if it helps, you guys could write it as x squared plus 0x minus 49, but it's really a difference of squares. So when you don't have that middle term, it should equal 0 in the middle. But you're still trying to technically figure out what multiplies to get you 49 and adds or subtracts to get you 0. So same thing. When that middle term is 0, it has to be the same number, but positive and negative. So like you could try 1 and 49, but that's not going to add to get you 0. But 7 and 7 would work. So that's what you guys want to use. So x plus 7 and x minus 7. So when there's no middle term, no b term technically, you have to have the same number, a positive and a negative, same number. That would be your difference of squares. So then for letter B, that's going to be your perfect square trinomial. Again, not expecting you to know that off the top of your head right away, but still the same thing as far as trying to multiply to get you 36 and add or subtract to get you 12. So if you list your factors of 36, you have 1 and 36, 2 and 18, 3 and 12, 4 and 9, not 5, 6 and 6, lots of factors of 36. So what multiplies to get you 36 but also adds to get you 12? Can't use 1 and 36, 18 and 2 aren't going to do it. 3 and 12, no. 4 and 9 adds to get you 13, not 12. So 6 and 6 is what you guys want. So this would be d plus 6 times d plus 6. Both positive to add up to 12. Both positive will multiply to get you 36. You guys could try C and D.